And we are going to be talking about non-proportional dilations today. So, as a reminder, if you have reflection, rotation, or transformation, you are just moving your triangles or your figures. Do y'all agree with that? They create congruent triangles. Yesterday when we had dilations, we created what kind of triangles? Similar. So that's what we're going to do right here. We are going to transform. Can y'all box these points, please? We are going to transform these by dilating about the origin. So number 1 wants me to use the rule 3x, 3y. If I multiply x times 3 and y times 3 for w, 0, 6, what am I going to get? 0, 18. And I then want you to plot 0, 18 on your graph and label it W prime, please. For R is 3, 3. If I apply the rule, what does R get and become? Be careful. 9, 9. And then plot 9, 9 as R prime. G is negative 6, negative 3. If I apply this rule, what am I going to get? Negative 18, negative 9. So I'm going to plot negative 18, negative 9. And then I want you to use your badge and connect these points. And what did we just create? An enlargement. Do you agree it's the same shape as this one right here? It's just enlarged. So we created a similar triangle that's bigger. What about number 2? Number 2 is xy 1/3 x, 1/3 y. What do we think is going to happen here? It's going to reduce. It's going to get smaller. So, we're using these same ones right here. Somebody asked about the double prime. The double prime is just there so that when you label it, you're labeling it something different than what we just did. So, what is 0, 6 times 1/3? 0. And what's 6 times 1/3? 2. 6 divided by 3 is 2. And I'm going to plot that, and this one's going to be really small. It's going to be kind of hard to plot, honestly. All right, what is 3, 3 going to become with this rule? 1, 1. Am I going too fast? Okay. 3, 3 becomes 1, 1. And I plot that. And then what is negative 6, negative 3 become? Negative 2, negative 1. And when you graph that, you can barely see it because it's right on top of that line, right? And what happened here? It was a reduction. Is it still similar to my original triangle? Yeah. Okay? If you multiply both the x and the y by the same number, you create similar triangles. If you move x and y by adding or subtracting or putting a negative, it's congruent. Because I didn't make it bigger. I didn't multiply by anything. Right? Today we're going to talk about what if I do something crazy. Open up your notes. And what if I only multiply the x or the y? So what I'm going to do up top real quick, I'm going to rewrite these points. And what I want you to do is I want you to do 3 through 5. Apply the rule to these points and plot it. Does that make sense?
Yeah.
So get started. I'm going to be doing it up here too, so if you get a little lost, you can look up. But apply the rule to these points and plot your triangle. So my first rule, x stays the same, multiply y by 3. Go. When you're done, look up to see if you are on the right track. Louder? The very bottom one? Oh, sorry. 3 through 6. You're doing 3 through 6. All right. Do we notice some things happening? What's the first thing you notice right away about all of these? Oh, I heard a bunch of different things, but I heard them very lightly. Can you raise your hand and say that again a little louder? Lynette? We created completely different triangles. Do you agree? These are no longer the same shape. If your head's on the desk, I need you to pick it up, please. Head up off the desk. Thank you. All right, Nick, what did you say? Only one coordinate was changed on each of these. Do y'all agree with that? We either changed the X or the Y. And depending on which one we changed, that changed our shape a certain way. So, we're going to answer these questions on the right to kind of summarize. And then you have a very quick Schoology assignment to complete. Everybody today has done the Schoology assignment in less than 10 minutes. I'm going to try to summarize this in about 5 minutes because the fire drill messed us up. So, first things first, which of the transformations are proportional? Proportional just means similar. Are any of these transformations similar? No. So the only ones that were similar were number 1 and number 2 on the front. Why? Because they were the same shape, different size. What about their equation makes them similar? Yeah, so it has the same number with X and Y. That's what makes them proportional or similar. So on your homework today, it's going to give you a rule, and it's going to ask, is it similar or is it not similar? And it may even say congruent. It'll be congruent if there's no number in front of X or Y. But similar, it's the same number in front of X. Not similar, it means there's different numbers in front of X. So which ones are non-proportional or not similar? Well, which ones are non-proportional? 3, 4, 5, and 6. How can you tell by looking at the graph? Not the same shape. Or not the same triangle. What about the rule? There's a different number with X and Y. So even though there's no number in front of this x, what number is actually in front of that x? A 1. So this one has a 1, that one has a 1/3. There are different numbers with x and y. A vertical stretch. What does the word vertical mean? Up and down. And what does the word stretch mean? So I'm going to say by the graph, you can tell it's a vertical stretch because it's bigger up and down. Which one of these had a graph that was bigger vertically than the original? 3. Well, in number 1, we're not going to, you're not wrong, honestly. We can write number 1. But number 1 as well, but number 3 had a vertical stretch. It's bigger up and down. What about the rule? How can you look at a rule and know it's going to have a vertical stretch? The number with what letter? Why? The number with y is bigger than 1. If the number with y, because y-axis is up and down, right? The number with y is bigger than 1. That's how you know it's going to be a vertical stretch. Okay? Since we're down here, I'm just going to skip to 12. What about a horizontal compression? What does horizontal mean? Left to right, side to side. And what does compression mean? Shrink or smaller. So it's going to be smaller left to right. Which one of these graphs was smaller left to right? Number 6. And how can you look at a rule and just know that's going to happen? Horizontal is going to be x. And so this is weird because we're not going to say less than 1. It is less than 1. But we're going to say the number with x is between 0 to 1. Because it's going to be a fraction. I don't want you to include the negatives in that. Write that down, please. The number with x is between 0 and 1. Can I move on? Alright. Do you think you could finish these 2 on your own? Which one was the horizontal stretch? Number 4. Horizontal means, stretch means, so it's bigger left to right. And if it's horizontal, what is it going to affect? The number with x, and stretch is going to be bigger than 1. Oh, what number was that? Number 4, thank you. I forgot to write a 4 up there. And then last but not least, a vertical compress was number 5. Vertical is up and down, and compress is smaller. Vertical affects the y. And the number would be between 0 and 1. It's a fraction. Okay. You could honestly start your Schoology assignment and probably only have 2 left. Hold on, I need everybody to look up. On here, your Schoology assignment is worksheet 7. That is going to be due tonight. Everybody needs to get that done tonight. Day 8 transformation quiz. This quiz review, it's a review. Tomorrow you have your big quiz. Today's quiz, potential drop grade. Today's quiz, did we realize we didn't know some things? If you took today's quiz and you're like, ooh, today's quiz was droppable. Tomorrow's quiz is not. Tomorrow when you walk in, I'm going to give you that quiz back and we're going to go over it. But I want you to do this quiz review tonight so that when you walk in, you can say, Miss Olivars, I need you to go over number 5 because I do not know how to do it, and that's going to be on my quiz tomorrow. Or you're saying this tomorrow, so it'll be today. All right? This quiz review is going to set you up for what you need help on. So if you don't do it, I'm not taking it for a grade, but you probably won't do well on the quiz tomorrow. Do y'all get me? All right? So if you do it, then you can come in and know exactly what you need help on, and I'm going to go over those questions that you ask me. Okay? You have the rest of the class. I hope you can get started on that. I know we only have a couple minutes, but go.